Hi everyone. In this lesson we're going to go through the different parts of a circle as well as talk about things that are involved in the rest of this chapter. So you might be already pretty familiar with circles. So on the right hand side we have a lot of things happening here, but this whole circle here is our circle. And in geometry we use this symbol to represent the word circle rather than spelling it out, and this letter to talk about its center, which we're going to define in a second. So you can see in this circle here that L is right there in the center. So let's actually use our definition here for center. Now you can find all these definitions in my notes online, but if you want to write them with me here, this is a good point. So the center is the point equidistant from all points on the circle. Just meaning that this center point is basically in the middle of every single point that exists along the circle. And then the next definition that we have is a diameter, and that would be what I'm going to call a chord, and we'll talk about the definition of a chord in a second, that goes through the center. Now, looking at our diagram here, one chord that we might say is C to F, or diameter. So the way that we would say that is just CD and then just a line over top, just like it's a line. Now my radius is any distance from center to circle. So there is a bunch of possible radiuses that we might say, but let's use D to L as a radius diagram. So again, we would say DL with a line over top. Now a chord is a type of line that goes through a circle, but it's any line that connects the circle. So a chord is not quite going through the center every single time. So a chord, we would say, is something like A to B. Because if I look, this A is on the circle and I travel through to B. So this is what we call a chord. The reason why a diameter is a chord is because it does the same thing. It's just the diameter goes through the center specifically. So we might say that the chord in this case is AB with a line. Now a tangent is a line outside the circle that touches it once. It touches the circle once. So there's only one tangent in my diagram here, and that would be this line right here, the tangent line. So it just touches right there at A, so that's why that is a tangent line. Now my next one is the circumference. So essentially that is what we call the perimeter of a circle. So that goes all around the circle. So again, just visually, your perimeter is just all around the edge. We talked about that earlier in the year. Our next definition here is an arc. So an arc is just part of the going around the circle. So C to D, for example, this way, this is what we consider an arc. So it's this length. So I refer to this as the crust, and we'll do more of this later in this chapter. But the arc is just part of circumference. Now there is some new terminology and new writing here. So if I want to say arc CD, I still use the letters, but instead of using a line, I kind of use like an upside down smiley face. If we use a line, that actually is something different. Now a sector is what I'm going to just refer to as a section in center of the circle. So it basically starts from, I don't know why that moved, starts from the center out. So this whole thing is what we would call a sector. So I think of it as like a slice, because it kind of looks like a slice of pizza or pie. And your segment is the area trapped between a chord and circle. So we only have one chord in our diagram. So right up here would be an example of a segment. This whole thing, its area. These are really hard to solve for. So we're not going to really solve for the segment itself, but we have certain properties. And finally, a secant is a line that goes through the circle. So there's only one secant, and that would be if I actually extended my chord. That's why I had dotted lines here. So if I extended this chord, this would be a secant line. So tangents touch once and secant lines touch twice, essentially, is the big idea. Now, if you want to see another visual diagram, if you scan that QR code on your notes, you'll be able to see a different version of some of these definitions, which might be helpful to see from a different perspective or a different voice, essentially. And then, just so you are familiar with the word concentric, because this gets used a lot, a concentric circle is a circle with the same center but different radius. So when we say concentric, it means like they basically we think of like a bullseye arrow. Like if you think of Target's logo, for example, looks something like this. Right, next time you go to Target, let's assume that this is all colored in here. Okay, so these are all concentric circles, right? Because they all have that sort of center point that we can think of. So now let's talk about what tangent lines are. So we have tangents touch it in one spot, and there's two main types of tangents, the external and the internal. So external tangents are tangents that stay outside of the circles. So let me draw you an example. So these are two tangents that touch here and here, and external would just be outside of the circles. And you can see that it's like kind of on the outside edges of the circles. So another external tangent might be, no, that wasn't that good of a drawing, but another external tangent might be one that looks like that. Okay? And then there's internal tangents, and they pass between the circles. So if I draw, again, the same two diagrams, more or less, if I do a tangent from here to here, assuming I draw that, okay, and then here to here, so you see how these are tangents to the circles, but they only touch them in one spot and they go in between. So when I actually like overlap them, you don't need to draw this, but when you overlap them, most circles, most sets of circles will have 4 tangents, 2 external and 2 internal. All right, so that's kind of overlapping them. There is some unique ones, but that's the general idea. And then tangents from a common point. So if a circle has tangents that start at the same location, that's not a good circle. I still don't like that. I think I can just do, oh yeah, here we go. That's much better. Don't know why I didn't do that before. Okay, so if I have a point here that's tangent to the circle here, as well as tangent to the circle here, these two things are equal in length. Now what's really helpful, and for everybody that loves triangles, because I know we love them, and we're going to kind of revisit them again, tangents actually form 90 degrees. So this is kind of important for us because we can now use things like Pythagorean theorem. And so we now know that these two triangles have to be the same, but in general, we know that the tangents are the same from a common point. Okay? So let's look at an example. So we know that the Earth's surface is rotating, the satellite is rotating 120 centimeters or miles above the surface. The radius of the Earth is approximately 4,000 miles. So what we want to do is we want to use Pythagorean theorem, because we know if this is a right triangle, this is 4,000. This is, we don't know, but this length is 4,000 plus the 120. So the hypotenuse is 4,120. So we can do 4,000 squared plus b squared equals 4,120 squared. So when I solve this, so 4,000 is going to be some big numbers here. 1, 2, 4, 5, 6, 1,600. and then 4,120 times itself gets me 169,74400. So when I subtract this 16 million, I'm just left with, I think that goes away. So I get b squared equals 974,400. And now we can take the square root of that to get our final answer here. So when I square root that, I get approximately 98.7. We'll go there. So this distance here is 98.7. 987.1. Okay, so that's why we like tangents, because they make 90 degrees if we can form the triangle. Whereas with this one, these are a common tangent from H, so that means these are equal lengths. And the way that we want to represent that is that 4 plus 2a has to be equal to 5a minus 32. So if I just subtract 2a from both sides, and then add 32, I get 36 equals 3a. Divide by 3, a would have to be 12. So when we plug it back in, we get that this side here would be 28 as well as 28 here. Okay, so that's everything we need to know for circles. You should have some practice problems to try now. Feel free to come back and watch this video for anything else. See you in the next one.